And welcome to Shrigleytube TV, episode 22. This is Sunday night's video. We did a Tuesday night last week where we did the t-shirt competition. I'm not going to go on about that in any way other than to say thank you for all the amazing comments. I've really enjoyed reading through them. We'll go through all that on Tuesday night and we'll do the draw on Tuesday night and do the 5 t-shirt winners. So if you've put your name down, if you put your favourite sounding engine down, great. But please, after tonight, no more, because I've got to cut them all out and put them in the Christmas stocking ready to be pulled out on Tuesday night. So tonight's video is about engineering from the workshop. Obviously since Tuesday I had an engine that I put a set of rods in, so we did a bit of time lapse, bit of talking, a bit too much talking probably, but anyway, did all that. So that's all ready to go on for tonight. And then we had a visit from the stock car Hot Stocks guys. They do like a strip down. I didn't video that bit, but one of them turned up in this really nice car, so we did a video on that. We had Bergerac a visit from him, showing us his favourite sounding engine on a YouTube clip. And we also got the crankshaft back from Grinders, where we did the offset journals, make it a 65mm throw. So that returned from the Grinders, so I've got a dry build on, and did a little mention there to Shillbill, who made a comment about why don't you. Anyway, we won't go into that. You'll see when you watch the video, hopefully. Right, hope you enjoyed tonight's video. I'll see you on Tuesday night and we'll do the prize draw then. Right, YouTubers, we're going to do a little job together now. This is an engine that belongs to a chap called David in the ctcrc. He's only owned the car for a couple of years, but prior to that I did do the engine, I think around 2014 for the previous owner. So it was a 998, then David sent it back to me earlier this year and it got refreshed and we turned it into a 1040 with the modern cam, etc. And it did good power, to be fair, and he raced it throughout this year, and we've sort of had a bit of a chat, how can we make it better? And I said, well, really, if you want to hang the RPM on it, we could do with putting steel rods in it, because it's on the standard rods at the moment. So I've got him a set of steel rods to go in it, and I thought we'll change this sump as well. This is nothing wrong with the sump, this is a Mike Hanna sump, but we run them on a standard sump now with my baffle plate, so a bit of a weight saving there. So we're going to put him a sump plate on as well, a set of steel rods, maybe some bearings. Well, I don't know what I'm going to find. It looks like it's been a little bit warm at some point. It's been up to sort of 99. I hope that was in the paddock when it was idling, not when it was on track wide open throttle. But anyway, I'm sure David wouldn't tell me if it had. So we'll pull it apart together. Anything exciting I see, I'll pause the video and we'll go from there. Okay. Right, we've just got to a point on this engine. I've started taking the cam cover and the throttle linkage off, and then you might have noticed on the time lapse I just checked all the shim clearances. It's just to give me an idea of where things are at, because while it's coming apart I can do something about it. So I'm looking at my clearances: 810, 911, 99, 8. We can trim them a little bit, but the basic within a thou of what I'm trying to say is for an inlet valve I go one thou either side of 8, so that's 7, 8, 9. And an exhaust valve I go 1 thou either side of 10, which is obviously 9, 10, 11. So we're all in tolerance there, and I thought we could just do the cam timing together. Now it seemed a bit weird doing the cam timing taking it apart, but as he's not reported to me anything like, oh, it's got a flat spot or anything like that, I'm probably not going to mess with it. I'm just using the pointer for TDC at the moment, which might not be 100% reference. I normally use a paint mark on the flywheel, a big diameter, but that's not. Anyway, I can see originally it was timed in at 178, 163 I think it says. So what I'm going to do is I'm going to back it off now. So if you imagine, what we've done is we've come round to in clockwise direction to top dead centre, which if we look in here we'll see the valves, the inlet and exhaust valve. If I can actually get in there, you'll see they're on what we call rocking. So what I'm going to do is I'm going to pause the video because someone's at the door. Right, sorry about that, just a doorbell ringing. So we can see that both valves are held open ever so slightly on overlap, And if we go to number 4 end, we can see that number 4 is firing, so both valves are fully shut and the lobes are pointing away from them. So what I'm going to do is, I'll zoom out a little bit. I'm going to turn the crankshaft anti-clockwise now, because if you can imagine, what happens is, as we come to top dead centre, we're approaching top dead, the cam comes on lift and pushes the valve open. So to measure its lift, we put the DTI on the end of the follower. That's what that is there. If I push that, you'll see the needle move. So as I turn the engine backwards now, the cam follower is going to come off lift, and that lobe is going to come round away from the follower. So we will know what the lift figure is at TDC. It should be 178, but I highly doubt it. So we go around. So I'm going anti-clockwise now. So that's 50 thou, 100 thou, 150, 170, 175, 180, 181. So 181,000. So I suspect that the TDC may not be 100% correct, but I will check that when the head's off and we put the new rods in. So when we put it back together again, what we'll do for now is we'll just put a bit of a paint mark next to the dowel that's been selected, so we can reference it when we come back together. Okay, got the head off David's engine now, just having a quick look. All looks like it's been sealing properly. The O-ring's in a good position there for the high pressure oil way up to the top. That's where the oil feeds the cylinder head. And then obviously it drained down a tube that goes into the block, but because this head has got valve guard oil seals, we don't use this drain. It's got a bung in it, if you can see it down there. And then what we do is we allow all the oil to bathe in the cam, or the cam to bathe in the oil, and then it finds its way down the timing chest at the front. So it just gives it that extra bit of lubrication, but because we've got the valve guard oil seal, we can get away with that. It doesn't make them smoke or anything. So important parts for me here are just looking at the bore. We can see still got a nice crosshatch in it. I don't think there's any issues at all with the engine so far. I think it's going to be a simple case of put the rods in it and put it back together. Like I say, of its 12-hour lifespan racing, it's probably only done 3-4 hours, so it just doesn't warrant all the parts put in the bin and changing just yet. So I'll pull the sump off it next and we'll have a look. But looking at this all around here, we can see that silver ring is where the Wills ring lands on the top of the liner. It looks to be sealing nicely, so yeah, looks like he's been taking good care of it. Right, I've got the sump off the 1040 now. I'm putting the rods in it, and I should have checked it hadn't got oil in it, because it did have what looks to be about 4.5 litres of oil. Luckily we've caught it, so we should have checked that. Crank looks mint, no problems there. Pump looks good, pistons look good, bearings look a little bit on the polished side, but I'm going to change them just as a matter of course. Obviously this is the standard rod, and this is the steel rod that I'll be changing them for, just to give him that little bit more of reliability and safety margin. So I'm just in the workshop here, and we've had that guy from down the road.
It's warm in here, that's why I'm here.
I thought you come to see me because you like me.
Oh yeah, of course. Yeah.
Oh, hang on, let me get the microphone. Right, now Bergerac obviously wants to take part in the win a t-shirt competition.
Of course.
Because he doesn't want to pay for one, because he squeaks when he walks. But now, I believe you've got a video there of an engine that you think sounds the best.
Obviously.
So this is a bit sort of, you shouldn't do this, should you, in YouTube, but we're going to play a video on his phone through to my phone, and hopefully you guys can appreciate it.
Obviously the best sound is one of these.
Sounds like a 4Bs.
There you go.
Wow.
Lance's finest.
Is that
Of
like
course.
a 2-litre short stroke thing, is it?
Pinto engine, I think.
No, don't be silly. What, that's a V6,
Yeah,
is it?
Yeah, 2.4.
Is that the Ferrari?
Ferrari Dyno, yeah.
Right, 2.4. Yeah, so it's
Definitely the best sound.
did sound good, mate. What was it? Revving to about 10,000.
I'd say so, yeah.
Right, so I'm
So that's my
not.
vote.
Well, yeah, I'm a bit upset about this. So you're genuinely just there to keep warm.
Of course, yeah.
Mate, you're out of order, mate.
I'm almost about to take my jacket off because it's so nice.
Oh, mate, it's tropical. Okay, just gonna start turning this bearing down in my little jig, which is an old Hillman Imp conrod, which I use to hold two bearings opposite each other and machine the bearings down. Now the reason I do that is these are the bearings here. They're mini ACL ones. They're good bearing, these. Now the Mini Cooper S, the early one, was on the same diameter pin as the Imp, which is 1 5/8. So this obviously is a mini bearing, but it ends up at 740 thou wide. So I'm just going to go in now with this nice radius tool, actually the same tool I used to do the crankshaft, and I'm just going to shave it down until it gets to the correct width, and then we'll lock the stop up and use the cross slide to repeat it for the rest of them, and then we'll have our bearings then for David's engine. Right, just on with David's engine, got the new rods on the old pistons, bin the old bearings, put a new set in while we're there. They're just like a serviceable item, the bearings, so put a new set of ACL bearings in, and got the bolts ready. They're all got the lube on the shoulder, etc., on the thread, ready to be torqued. So I'll assemble this now, but what I wanted to say was, interesting, the new steel rod is a weight saving of 100 grams over the original rod, so nice little weight saving there. It makes it a bit easier for the crankshaft to cope when it's got to hurl it round at high speed. So I'm going to crack on with this now. Hopefully I'll get the pistons and rods in and get the sump painted, and I'd like to try and get the sump on before I go home, so I've got a good chance of getting it on the dyno by tomorrow afternoon then. Okay, we've finished putting the engine back together now. I didn't bother recording that because it was a bit painful the amount of times it takes me to do it, so I've just concentrated on putting it back together without the camera. It's all back together now. The only difference from when the engine arrived is obviously it's got the steel connecting rods with the new bearings in, and it's got the Posh baffle plate, which runs with the standard sump. So if you look, you'll recognise the sump has been totally standard, apart from it's got the Dash 8 feed on it there, which I'll explain in a minute. But the clever bit in an Imp sump is in containing the oil in the sump area rather than putting an enormous sump on it. Obviously any weight that's behind the back wheels, we try and remove it because we want to keep the weight as far forward as possible. Not that the Imp engine is particularly heavy as far as engines go, but it does hang out behind the back wheels, so obviously it's a pendulum. So this feed pipe here, this Dash 8, I was just bunged it for the time being, but the reason I've done that is all the problems with Hillman's having oil starvation come from the cargo on a long left-hander at high RPM. So like Cascades at Alton Park was always the big test for me. If you could make it work round Cascades, you'd cracked it, and that's when I developed the sump and the baffle plate and made it work with the standard sump. So it works great, but we have a problem with the Hillman where the oil comes up the timing chest, and normally this breather will blow across here at full diameter into a catch tank. So over the period of like a 40-minute race, you might lose half a pint of oil, which isn't really acceptable because obviously the sump's only got 4 and a bit litres in it to start with, so we can't afford to lose that oil. So decided some time ago now, what we do is we'd have a nice catch tank for it to breathe into with an atmospheric breather on it, but at the bottom of the catch tank we put a Dash 8 feed that runs back round into the sump, so that the sump's oil level is always maintained at maximum. So the engines are good now, they don't use any oil, they start off with the same amount of oil in the race as they do at the end. So this is just a way of getting around it so that we keep that oil level up, especially when people are trying to do endurance racing with them. You don't want the oil level dropping. Right, now there's a filter housing on top of here which I'll explain in a minute, but I didn't want to get too carried away with it, but I was going to explain what I've done so far, which is I've just started the engine up and let it idle for like maybe an hour, 3/4 an hour at least. So it's got warm, put the coolant pumps on a couple of times, just let him make friends, let everything, in theory nothing touches, doesn't it? You know, the oil stops the bearing from touching the crank journal, but just in case there's any debris from my build. You know, I've had it apart, bits of cloth, bits of grey glue, all sorts of things. You know, we're not building these engines in a laboratory, we're just in a workshop with dust, etc. in the air. So what I do is I let them idle, but I let them idle for a specific reason, and that is every oil filter, if we look at this one, which I've hacksawed open, very simple device. The oil comes round the outside behind that orange flap there, that's like a seal. That's actually a one-way valve, that meant to be, just to stop the oil from running out of the filter if it's upside down, like on an MGB or something. So it comes round the outside, and these little concertina flaps catch the debris, and then the oil goes back up the middle, in there, and into the engine. Now, every oil filter that we fit on a Hillman has a bypass valve, so you see that valve with a spring on it, and the reason that's there is because that area that filter covers, that grey cardboard type material there, cannot cope with the amount of oil flow that the pump can push through it. If you think the pump's quite clever, well, the whole system's quite clever. The pump is driven directly off the crankshaft, so it's got to produce oil pressure at idle speed. So at 1000 rpm it's got to have like 20 psi of oil pressure, but it's also got to produce oil pressure at 9000 rpm. So because it's direct drive, we get massive amount of oil being pumped at 9000 rpm, you know. And what basically happens is, because we have something called a bypass circuit, or we call them a pressure relief valve. So inside this little valve here is a plunger, and you see the hole on the side there, on the side of the plunger. Not zooming quite how I wanted to. So in there is a plunger, and then this opens up into a little channel called the bypass pipe, and it basically blows the oil back into the sump. So when the engine's after sort of like 2500 rpm, you'll notice that your oil pressure will climb to 50 psi, which is what the relief valve's set at, and it won't go any higher. Now that's because the relief valve's open, so what it's doing is basically the pump's producing more and more fluid the faster that it goes round, but the bypass valve is maintaining that pressure by, there's a plunger on a spring and it gets to that pressure. Sometimes they used to say 55 on top, and this one hasn't got it, but anyway. So the plunger determines the amount of pressure. When you see people that run like 100 psi of pressure, you'll notice they have like a screw in the end there, which puts more preload on the spring. That's called an adjustable pressure relief valve. But any more than 50 is just a waste of energy on an imp engine. So we just produce 50 psi of pressure. It's absolutely ample. So the plunger blows off the oil, and then this little passage here is on the side of the block, and it just basically blows the oil back into the sump. So at high RPM, once that relief valve's open, there's a lot of oil. You know, at 8000 RPM, the oil that must be going past that bypass valve or relief valve and into the engine is absolutely massive. So that's how we know that the valve in the filter really it's there for a very specific reason, and that is so that the pump can be allowed to you know, filter as much of the muck out of the oil as possible. But at the same time, if the engine is doing high speed, we don't want the filter restricting the amount of oil going into the engine, so it has the bypass on it. Now this is an earlier type of filter housing, which, you know, has the element inside the steel canister, and you can see this one has got its bypass valve separate, so it's just inside the casting there. So if the filter were to block, the engine would still get oil because the bypass valve opens. That was the original theory anyway. So always be careful when you're fitting an imp oil filter. Some people like to fit the bigger filters off different cars. Just make sure that when you eyeball it through the hole there, you can see a spring in the bottom, and that spring obviously is the back part of that bypass valve, because we can't restrict the volume of oil going into the engine. It's no good. So just to go through this a little bit better, the oil comes in here and obviously goes off to the cooler through the filter, and then it's filtered and comes out of here. This goes into the main gallery of the engine, and then this is your bypass. So it's quite a lot going on in there, you know. It's quite a complicated thing. It might be a bit hard for you to understand the way I've explained it quite badly, but anyway, that's what I want. That's getting back to it 7 minutes ago when I said that's the reason why I leave them idling, because I know that if I've left any fluff or anything in debris in the engine, the filter will catch it, and it'll be caught there in the concertinaed cardboard for the rest of its filter life, and then we'll spin this off after we've dynoed it, put a fresh filter on, drain the dyno oil out because it's on me basic running in oil, and then he can put his race oil in and go racing with it. So I'll stop waffling now, and we'll get a tune out of this and see if it's got good horsepower. Okay, just on dynoing the 740 with the steel rods in it, and it's been really good. Been tweaking it a little bit here and there, trying to get him a little bit. I don't like sending them out as they came to me. I was like to try something a bit different. So it seems to be responding very well. It's got really good torque at, like, we go wide open there, we're seeing 78 at 4.5. With these 4-speed cars that are relatively heavy, that torque there will really help them out the corners. Let's see if it hangs on. So I'm backing the dyno off now, so that's 6, it's still holding 75. Yeah. It's still holding 70 at 8.5 there, or 8 and a bit. We'll just go and do a low end again. But yeah, I'm really happy with this, it'll be good. I think you'll like it. The big question is whether I fix the oil leak or not. 6,075, 5,500, it's holding a steady 75, 78 foot-pound. Yeah, be good that. Right, let's go and see if the oil leak is... Good afternoon, YouTubers. I had a phone call from the crank grinders to say that the crank that I'd machined last week was ready for collection, so I just nipped out there now and quickly put a piston and rod, one of the motorbike pistons and rods, on the crank so we could see how it was going to go around in the engine. Now this is the second stab at the job, because if you remember this was last week's one where I'd mentioned that one of the subscribers, actually the guy called Hillbill Chillbill, which is Sheddock Customs, and my mate Paul, and his message to say on one of the messages, why don't you do an offset crank? Because the when we did the initial dry build of this, the piston fell short by about 3mm at the top of the block, and I was saying, oh, I'll just yak the top of the block off to make it the piston level. And obviously he's made the comment, well, you've got the material, because you're starting off at 42mm or 1.5/8 and we're going down to 36, so can you make it work? So if you remember, this is the crankshaft that I got all excited about. You can see it hasn't took hardly any material, loads of material off this side and barely touched this side, which has given us a greater offset between here and here. So we now have 65mm of stroke, which on an imp with a 74mm piston gives you 1120cc. And I have to say a big thank you to Paul from Sheddock Customs, because if I turn this over now, I can't believe how well it's worked out. It pulls exactly level with the top of the block. So yeah, fantastic result. I can't wait to get this this built together. Unfortunately, I've got quite a lot of, well, I say unfortunately, I'm grateful for the work, but I'm absolutely manic busy with imp engines for customers at the moment, so I'm going to have to put this to the side. But I was thinking, if I get a little bit of time at Christmas, if the job backs off a bit, I'll and I feel like I'm where I need to be with progress, I'll drop onto this for a day or two, and we'll try and get a motor built and get a tune out of it, because it'd be really interesting to see how this lightweight piston does. But that was going to say, the first thing I am going to do is I've consulted Bob at B&J and told him about what I've done, and once he's finished shaking his head in pure sort of defiance as to my ability to mess about, he said, look, you know, we'll put it on the balancer and we'll have a look and see how it's been affected, having all that weight removed off that journal. So we'll take it to the balancers next week and get it balanced first. Got my pal Stephen here. Stephen.
Good evening, you alright?
Yeah, good. Stephen's a stock car racer and this is his everyday cruiser. What a beast it is. Tell us a bit about it, mate. What is it?
This is a 2017 Dodge Charger Daytona 6.4 Hemi.
A 6.4 Hemi. Wow. And it sounds absolutely awesome, mate. That's one hell of an engine, that.
Yeah, it's does the job.
How many horsepower?
485.
Wow. And 8 gears?
8-speed automatic.
Can we have a peep inside?
Of course we can.
Cheers.
It's a bit dirty at the moment.
No, it's mint, that. Wow. That looks smart as anything.
Seats.
Is it? And cooled?
And cooled.
Yeah, American spec, eh?
All the gadgets and whatnot.
Mate, that's absolute machine. Has it got a tow bar for your stock car?
Not in here.
Right, does it make a noise?
It definitely does.
Brilliant. Can we hear it, please? That's mega. It's got some bark, that, hasn't it? Wow. Mate, it's like an aeroplane in here. Crikey. Wow, well, thank you very much for showing us around.
It's no problem at all.
Shame it's raining.
I know.
Never mind.
You could have spit in it, but there we go.
Oh no, mate, you scare me to death in that. Right, this is my closing video from tonight, so you know it's the end of the video. Live from Office Passat. We've got Mr. Snorrison behind me. I don't know if you can hear him snoring away, but he's whacked out. So we're just live from Costco car park, saying good night, and I hope you had a great weekend. I'll see you on Tuesday night for the draw on the t-shirts.